Let's talk about how to write your conclusions for the two-way ANOVA on penguins. So to write your conclusions, the first thing you want to do is really stop and think about the penguins. What's up with the penguins? And remember our questions for the two-way ANOVA. Go back up to the questions and look at what they say. Scroll up there, questions for two-way ANOVA. It says the two-way ANOVA will allow us to answer the following research questions. 1, controlling for the species, is body mass significantly different between the two sexes? 2, controlling for the sex, is body mass significantly different for at least one species? And 3, is the relationship between species and body mass different between male and female penguins? So these first two relationships are referred to as main effects, while the third point is known as the interaction effect. We already went over that. It's just to review. I wanted to point this out to you again. Next, go back up to where we talk about the hypotheses for the two-way ANOVA. Let's review those real quick. We need to think about that for answering our question. Remember, we have the following hypothesis tests. The main effect of sex on body mass, our null hypothesis, was that the mean body mass is equal between male and female. And the second one was that mean body mass is equal between all three species. And third, about the interaction between sex and species, the null hypothesis is that there is no interaction between sex and species, meaning that the relationship between species and body mass is the same for all males and females. Or you could say that the relationship between sex and body mass is the same for all three species. Just two different ways of putting it. Then go look again at our summary statistics, that table that we got from the summary statistics preliminary analysis section, where we can see that the mean value for each species by sex and the standard deviation for the mean value of each species by sex. And we can start to just look at that and see the differences. And then we can go look at our graph. Look at our graph again and start to see, oh yeah, that's right. I remember there were some differences among the species and between males and females. Okay, now we can start to pull these different elements together. In addition, let's look at the output from the ANOVA. This is the ANOVA table. Remember where it tells us the significance value for the main effects of species and sex by species, interaction term. And how would we state our conclusions? Now, we already saw that we could state it very simply as controlling for the species, body mass differs between the two sexes. Controlling for the sex, body mass differs among species, and that the relationship between body mass and species is different between males and females. That's a really simple way of interpreting that ANOVA table that we just looked at. But to put it more formally, we could better say, we found that male penguins are, on average, larger than female penguins across all species. State your F statistic. Here, F equals 406, and the p-value is less than 0.001. We can also say size differs among species. And in this case, we don't yet know what's different, but we can state our F statistic and p-value from that ANOVA table that we just looked at a second ago. And we can also state that there is a significant interaction between sex and species. F equals 8.7, p equals less than 0.001, meaning that the relationship between species and body mass differs between male and female penguins. Now we can look at our contrast, the linear hypotheses here from the Tukey's test, to try to tease out a little bit more about what's actually happening. And this allows us to compare species pairs. Right away, again, we went over this before when we talked about pairwise comparisons, but just to remind you, when you subtract the mean of Adelaide from Chinstrap, the difference is 26. And here we have a standard error, the t-value, the p-value, it's not different. And we're also comparing Gen 2, Adelie, Gen 2, and Chinstrap, and we can see that Gen 2 and Adelie are different, Gen 2 and Chinstrap are different, but Chinstrap and Adelie are not different, right? So how do we state that in our conclusion? Well, informally, in our worksheet, we already saw that it's stated here for us, body mass is not significantly different between Chinstrap and Adelie. Adjusted p-value is 0.83. Body mass is significantly different between Gen 2 and Adelie. The adjusted p-value was less than 0.001. And body mass is significantly different between Gen 2 and Chinstrap. The adjusted p-value is less than 0.001. So that's a quick and dirty way of stating the results from the table that we just looked at. But more formally, we could state in our conclusions, in particular, Gen 2 was 1,377 grams plus or minus 39.10 standard error. I got that from the other table, not the table we just looked at. I got that from the MultComp package, or no, the Agricole package table. Larger than Adelie, and that's from the Tukey's HSD, and there's a t-value and the p-value from the table we just looked at. And 1,350 grams plus or minus 48.13 standard error larger than Chinstrap. Tukey's HSD T 28, P less than 0.001, while Chinstrap and Adelie were roughly equal in size. Tukey's HSD T equals 0.58, P equals 0.83. And again, that was from the table that we just looked at. This is how to state it formally in your conclusions. Now, if we look at this great big messy table of multiple comparisons of all the means that we had in our output, that's a lot, right? But if we want to write this as our conclusion, we can state it like this. Male chinstraps were the largest of all penguins measured at a mean body mass of 5,484 grams, plus or minus 36 standard error. The next largest was female Gen 2 at 4,679 grams, plus or minus 53 standard error. That's all from that table that we just looked at. Further, we could state that male Adelie and Chinstrap were similar in size at 4,043 grams plus or minus 28 standard error and 3,938 grams plus or minus 78 standard error, respectively, right? So that means that the Adelie is the 4,000 and the Chinstrap is the 3,900, while female Adelie and Chinstrap also overlapped in size, 3,527 grams plus or minus 39 standard error, and 3,368 grams plus or minus 53 standard error, respectively. That's how to state it more formally. And then you look at the graph, you can see the same pattern coming out in our results. Again, female Adelie and Chinstrap are not different, but Gen 2 females are larger than females of Adelie and Chinstrap. And then comparing the males, the male Adelie and Chinstrap are not different, but the female or the male Adelie is bigger than the other two species. So this is how you can interpret your results. I wanted to give you a better idea of writing the conclusions. Please use this in your lab and your homework and in your final papers. Thank you.